also destroys the bento structure, and especially the short campaign is the point that we want to make, which is not very favorable. What we have developed is a system-sensitive approach, and we have exactly looked at what nature gives us and how we can somehow overcome the impact that man has on the system, on the ecosystem. And we have found a solution that we say that we will pick up sediment in areas where the speed of the water is not big enough for natural transport, suck it and pump it to areas where we know the exact speed of the water and where this speed of the water is big enough for quasi-natural transport in the downstream area. So this way we just help the system come into a equilibrium again. We have developed automatic and half-automatic machines in order to pump or suck this sediment to certain areas, and but they are equipped to any sizes. For example, on the left side you can see the fully automatic vessel that we developed up to sizes down to 40 meters. On the right side, vessel size 2 would be a diesel-driven machine which goes down to 15 meters. And we have half-automatic or electric-driven, manually driven equipment that we can use. Or we could even go down to dredging depth up to 150 or 200 meters. So depending on the situation, we equip our equipment suitable. We have done research together with the University of Aachen. This is a model of a hydropower plant. On the left side you see that sediment is put into the river. That's the sediment that we took out on the upstream side. It's the sediment is going through the trash rack and is sucked into the turbine area and will go with the current in the downstream area. One example here we have done for the utility RWE. You can see on the right hand side, it's the intake area of the river Ruhr in Germany, and into this reservoir you can see going up how the sediment has been transported into the reservoir, and on the north side of this picture, on north right side, there is a hydropower plant, and we have installed our machine to go back and forth in order to suck sediment and pump it straight to the hydropower plant. That's the situation right there. The white building on top you see is the power plant, and the machine goes back and forth. It's led on a rope, and it goes there fully automatic, and then we have a pumping device is on the machine, and it's pumping sediment directly in front of the turbine. We have a installed capacity of 6 to 7 kilowatts at this turbine. It's very small. We want to make it small so that it's very efficient. We are only going here with 200 tons per month, and we have operated this site since December 2011. Our approach is that we first do a risk analysis of the existing or projected dam. The first step is the assessment of the situation, the initial situation, the original storage volume. Then the second step is determination of existing and operation volume, which means we assess how much volume of a reservoir is already lost and silted. And we develop, we derive the siltation and sedimentation rate of the dam and can estimate what the rest dam or probably dam life would be under consideration of the necessary operational range. Furthermore, we have also done some evaluations in Spain concerning further risk assessment. There was a sliding of sediment within a reservoir in the area of the bottom outlet, and that way there was a blockage of the bottom outlet, and the managers actually were ready to go to jail due to a fact that those security advices were not ready. Furthermore, we look at the risk of flooding caused to reduction of retention volume of the reservoir. This approach has been awarded as the Award of Excellence as leading global sustainable technology and innovation of the year. This has been done on Wall Street on December 1st, 2011. We're very proud on that by Fortune Magazine and Platts Global Energy Awards. Let me sum up. This approach has many positive environmental effects. One is it restores natural river morphology. It's environmentally and fish friendly, keeps the quality and the level of groundwater, the biodiversity in the river and the coastal areas of the ocean. Concerning the operation and economical effects, the reservoir can be used completely again, and you avoid enormous dam costs and or losses of generation. And one very important point is, as well as in the upstream as well as in the downstream area, you have a very wide reduction of flood risk. Final remarks, as I've said, there's a dramatic development concerning the decrease of global storage capacity. We have to be aware that the river is an ecosystem and sediments are an important part of this and integral part of this system. The major point is not take out sediments but leave them in. With using water, mankind does an impact on the system, and with this approach we try to compensate this impact. Last but not least, I want to remark that this solution is an ecological and an economical solution. I met last year the alternative Nobel Prize winner Juan Pablo Orega Silva, and he gave a presentation one day before the Rio Follow conference in Bonn, and he was describing the results or reporting about the results of studies that they have made concerning the population of fish, the population of whales, and population of dolphins in comparison with the sediment transport in the river. And Juan Pablo said that the studies were so enormous that they show the result that if you cut the transport of sediments in the river, you kill the life in the river as well as in the delta areas of the river. And that leads me to my last sentence is we have to be aware that all our life comes from the river. If we destroy the bento structure of the rivers, we actually are killing our basis of life. So we hope to contribute with our solution that we save the basis of our life. Thank you very much for your attention.
Solve it from the upstream. Now, downstream, is there anything that we need to do because of this application that is really need to be also considered while the application is there? Do we need to do anything downstream because of this solution and technique that you are applying?
I don't think that we need to do something downstream, because as soon as like for example downstream, if you have sediment in motion, the velocity of the water has to be only very small in order to have movement of sediment. So as long as sediment is in flow, it will go all the way down to the delta area of the rivers, and it should be there, because that is the basis of all life. So so we will, as long as we try to keep it in equilibrium, right? The situation right now is that you have too much sediment in front of the dam, and not enough sediment in the downstream area. So we want to bring this together, because what happens downstream, you have water holes, you have erosion, you have the higher speed of the water, you have groundwater levels that go down. With the higher speed of the water going downstream, also the groundwater levels going down. There's one example. I mean, Germany has much more water. In Germany, it's like this, that due to at the Dutch-German border, we have a sediment deficit of 2.5 million tons per year. This leads to 3 centimeters of soil erosion every year. In 10 years, it's 30 centimeters, and in 33 years, it's 1 meter, which means that the groundwater levels go down. So there is even in Germany, where we have so much water, it's an issue on the ecosystem and on the plants. So actually, we should be aware that we should keep sediments in the rivers and then let them go down the natural way. It's also flood waves without sediment are much higher, and they're much compressed. And sediment in a wave will make the dampen the wave down. You have less risk or the peak of the flood is much lesser, so it's softening everything out.
Thank you.
Mm-hmm. Thank you. Thank you.
Thank you, Dr. Bartelt. Now, we will have a presentation from Dr. Norbert Müller-Blanke. Dr. Norbert Müller-Blanke is the owner and managing director of TIA Technologies of Industrial Wastewater. He is an expert in the fields of membrane technology, flotation processes, and the biological processes. He will talk about treatment of industrial wastewater, case study from Kuwait. Please.
Yes, thank you very much. Ladies and gentlemen, thanks for being here. My company is dealing with the wastewaters from industries and also from municipality now since 25 years. We mostly do the pre-treatment of industrial wastewater treatment, also the final treatment of wastewater treatment in industries, and also for smaller municipal plants, we build the complete biological treatment plants. In the Arabic region, we do it as mentioned here in this picture, and these places. I'm going to talk about the management of industrial wastewater today, because it's different if you have industrial wastewater or municipal wastewater. And first I'm going to talk about the what to do with the industrial wastewater, just where to bring it. And then I'm going to talk about the processes for the treatment, especially for the pre-treatment, using the example of the Kuwait Central Industrial Wastewater Treatment Plant. And last but not least, allow me some words to the management operation of wastewater treatment plants. Before I start, there is two things you have to, I would like to mention. The industrial wastewater always needs a specific pre-treatment and a final biological treatment with a few exceptions. So the very specific treatment depends on the origin of the water, screening, pH regulation, heavy metal removal, oil and grease removal. This is all depending deeply on the kind of production in the industries. The pre-treatment is necessarily to be done before any further treatment and even before transportation in a sewer. The biological treatment is always the final treatment before discharge into environment or before reuse somewhere. Industrial effluents need other concepts, and municipal fluctuation is much higher. Some industrial wastewater can be treated together with municipal treatment, wastewater after the pre-treatment, but the municipal rate on organics should be more than 70%. So how to deal with industrial wastewater? That deeply depends on the infrastructure, what is possible to do with it. Is there a river, or is there the place for doing something with the wastewater? It is depending who is responsible for the wastewater. Is it the industry, or is it the municipality or community? Who is bearing the costs for the wastewater treatment? And it's also, last but not least, the question of competition and fairness, because if you say one company you have to treat your wastewater, you also say you have to say it to the other company. So you cannot say the one slaughterhouse has to clean the wastewater and the other slaughterhouse does not have to clean the wastewater. So the law and also the execution of the law must be fair. So the picture above shows the scheme of a fully treatment of water resulting from industrial production process. That means first you have the pre-treatment, then you have the biological treatment, and you can use the water for discharging into river, you can use it for irrigation, or you can use it for recycling into the company. It is, as you can imagine, it is cheaper for bigger companies to do this wastewater treatment than for smaller companies. It is more expensive specifically per kilogram of product or per 100 pieces of product. You have to think about that there is the necessity of to deposit the primary sludge. Also, the biological sludge needs to be used for something, and you need personnel for the wastewater treatment plant. The other and less expensive way is only to do the pre-treatment. You have less equipment necessary, less care of personnel, but it's also cheap for big companies and expensive for small companies. There is no direct reuse of wastewater possible because it's not cleaned completely. All expansions, which you have to do in your company, have to be agreed with the municipality, because if you extend your production, you extend your wastewater stream, and that means also the biological treatment plant is affected. The deposit of primary sludge is necessary, as mentioned before, and also you need some personnel for the wastewater treatment plant. Well, a complete no-go is direct discharging into the sewer, because you will find the problems in the sewer with stench, with corrosion, with blocking. You have also peaks, you have fat and oil and grease, pH, streams and toxic substances which are emitted directly to the biological treatment plant. So this is not, mostly not allowed or not to allow. The third possibility is just to bring the wastewater treatment plant centralized to a treatment plant for industrial wastewater. It must be a special treatment for different kinds of wastewater. That means you have low specific cost if many companies can be integrated, The same costs are for big or for small companies. So if you bring 1 ton of wastewater to the plant, it costs the same as if you bring 4 or 5. So specifically per product, it is the same costs. The environmental demands can be controlled. The well-trained personnel is possible because it's centralized and the costs are shared. But the deposit of primary sludge still is necessary to be cared of. Deposit of biological sludge also. You have no recycling possibilities directly to the companies. You have other recycling possibilities. And also, of course, you have the transportation costs to take into account. So to conclude, there are three opportunities in principle: the complete treatment by the companies, the pre-treatment by the companies, and the final biological treatment together with the domestic wastewater, and the central treatment of industrial wastewater in a central treatment plant. To be taken into account is where to go with the residuals from the treatment processes, how to finance the investment operation for the investment, operation, and disposal of residuals, and who takes the responsibility to keep the rules. I come now to this plant we built in 2010 or we finished in 2010 for the wastewaters of all Kuwait. It's near Wafra in the desert. And I want to show in this example some processes for the treatment and conception of a wastewater treatment plant. The situation until May is sketched here on this sheet. The wastewater is stored in the industries, in a ground tank or wherever, and is taken by these tankers to the desert and simply dumped into the desert. So there are big lakes, and that is not very nice to have, and it's not very healthy for an environment, as you can imagine. So the thinking about what to do was the characteristic for the Kuwait Central Industrial Wastewater Treatment Plant was that there were maximum 7,500 meter cubes per day to be treated from different kind of industries, and it was no dilution as sometimes possible with domestic wastewater, so you had to take the pure industrial wastewaters. The assumptions for Kuwait was the logistics should be facilitated, not too much different lines, not for each dairy, each fruit juice company, each slaughterhouse, one line. So this could not be possible. It should be simple and safe discharge of the tank lorries in concrete channels for a fast evacuation of the lorries. An efficient and flexible pre-treatment should be installed. The biological treatment is a must to meet the requirements. It must be designed to ensure a biota meeting the industrial wastewater. That means we wanted to use a high sludge age, and it is a typical ARS process we have also implemented. All requirements for sludge disposal, odor control, effluent limits should be agreed with the high standards of Kuwait EPA. The costs for investment and operation should be minimized, of course, and the plant must be extendable. So we came to the conclusion that we should have 3 different acceptance lines. One line for the waters with a high requirement on chemical physical pretreatment. One for, well, let's say simple waters from food industry but containing oil and grease. And the 3rd line for waters containing organics like sugar and so on, but no oil and grease, no precipitation was necessary. And there was a 4th line for some 20 or 30 cubic meters per day containing heavy metal. And the final treatment after this pre-treatment was in a biological treatment plant. So this is one of these lines now in complete. Just say it roughly, the pre-treatment on the middle line is just first to have a fat trap and a sand trap. That means the fat and all you can take out, and also a strainer, a screen. All you can take out without chemicals, without any physical treatment, you take it out. And then you add some chemicals, you have a precipitation and a flocculation process, and then we have flotation system to float all these mostly fat and grease up to the top and scrape them from the top. And then we have it's a bit sophisticated biological system in 2 cascades with one of these ARS reactors attached, and a 2-step sedimentation system with a pre-sedimentation and 2 lamellar sedimentation steps. So we go over this heavy metal line. This is the whole plant as in a scheme, line 1, line 2, line 3. The third line is just, one of these lines is only equipped for the flotation and precipitation process, line number 3. It's just a concrete building, but it's not equipped yet. We have only this fat trap and sand trap. In the others, we have the fat trap and sand trap and the flotation and precipitation. And the biological processes are doubled so that we have 2 lines for the biological processes as sketched before. You see on the top the odor control, and on the bottom the primary sludge treatment, which was chosen to be an incineration system. The alternative would have been a biological digester, like a biogas plant or something like that. But, well, it was chosen to have this incinerator. It's cheaper and it's more efficient. And then you see the sludge treatment for the biological sludge, which was proved also to be useful for farming processes. So we just had a centrifuge to thicken this sludge. This is a view to the pre-treatment hall from the top. This is when we built the plant. There was a 14 kilometers line for the power supply into the desert, which also increased the costs, of course. This is on the left, on the bottom left is the scrubbers for the exhaust air treatment. See them here again. Biological treatment plant, the hall. This is the biological treatment plant on the bottom and on the top right. And this is the sand and fat trap, one of the lines. Imagine also there are some mirrors on top. And this is because we were thinking about when management and operation of plant, all these moved parts must be visible. So the personnel must be able, with simple additions of mirrors, to view the plant, whether it's moving, whether it's working. So this is the daily routines which is necessary for management and operation of the plants, and it's simply to install such a mirror. So at the end we had this wastewater treatment plant finished. So we got some, 200, 350 meter cubes per hour or water discharge. We cleaned the water from a COD of about 5,000 down to 50, 60 milligram per liter. This is the opening ceremony. This is the whole plant from the top. It's on 500 times 500 meter. On the right, bottom right, there is the entrance of the tankers, the control for the tankers. They are controlled and certified to go to you see the brown lagoons, 1, 2, 3, or the heavy metal acceptance station. Empty into this station, then there is a pre-treatment hall in the middle and the biological treatment. Left-hand side from the biological treatment, there are also some big storage tank for the treated water, which is used for agricultural irrigation. It took around 1 year from the decision to completion of the plant, starting with taking the data, comparison of the alternatives, the cost estimation, and then making the decision, civil works, and so on and so on. And this ended up with the transfer and operation in, I think we had in May 2010, we put it on stream, the plant. And this is what I'm finally want to talk about, the special, the special attention we had to pay for the management and operation of the plant. You see that the process is going down from very varying around 4,500, 5,000 milligram per liter from the feed. Then after the pre-treatment, we had eliminated 40% of the COD, something like that. and the effluent is about less than 1% of the COD. But there are many management and operation works to take in care. That is the acceptance and the control of the tankers. The conditions for the acceptance were not known, so how could we control the tankers? What kind of tests could we do in a short time? Because we could not say tanker wait here for 2 hours until the results of the analysis is ready. So we had to improvise and find some short tanks which were safe enough to run the plant. Then we had to direct the tankers to the different lagoons. And also we had to do for the pre-treatment logistics. The chemicals had to be on site every time. The preventive maintenance, process control, the optimization, because most of the cost is the oxygen. You were talking about that. And also the chemicals we used for precipitation and flocculation. And then the biological treatment had to be paid attention, a very good attention. So we have normally with our plants something like a biological journal that you can follow up what had happened 1 week ago. What was the development of the sludge volume and so on and so on. So also here preventive maintenance was necessary, and we had to take care of biological sludge removal and treatment. So this was what to do, and just briefly to talk about two aspects, the technical aspect and the human aspects of management and operation. For the technical aspect, we had a clearly structured plan. All points were marked so that we said, you have to take the sample here, exactly here and not there. You have to go after this pump here, and so on and so on. We avoided all sophisticated devices, because if you take a measurement instrument, 2 minutes, okay. If you have a measurement instrument which is too sophisticated, you have to take more time for taking care for the instrument than for the process. The direct visual control was very important. I showed the mirrors before. Reduced number of control devices. The plant should be as much as possible self-adjusted, and it must be understandable functions. And for the human aspects, you have preventive maintenance, acceptance, the logistic had to be done, operation, and process control. That means the main thing we had to go after was accuracy, reliability, and responsibility. And the last word to responsibility, what is the management? The management needs to delegate responsibility to the staff. That means the management has to be interested also in the work of the staff. And this was one of the problems we had to solve, how to bring the management to the staff, and to say it must be a management also by clear instructions, by extended controlling. You have maintenance routines, you have process control routines, but also you have to blame, and also you have to gratify good work. So this is a very important thing we found in this context. So in our services for management and operation of a plant, always the training for management and personnel is included. Individual handbooks as a picture story and not made for juristic hedging. Individual development of routines, individual developments of protocols, individual program or table concerning the health of biology, and the management backing for the first time of operation. So thanks for your kind attention. I hope I could tell you something about what to do with industrial wastewater, about the processes for the treatment, and finally the management and operation. Thank you very much. If you have any questions, please.
Thank you very much. Very interesting presentation. It is very, of course, delicate and thing as far as the industrial wastewater everywhere. I think in the Gulf we do have the same problems. But this is, I understand that you are also operating the plant, right? You are managing the plant.
We had the manager on site. We didn't have the personnel, which was a mistake. So we should have also the personnel, but this was afterwards. Yes, we did the management also.
Okay. Just one thing about now the tankers. I have a number of questions, but the tankers, how much time they spend on site to discharge now? Because you are doing some checking also on their.
The tankers,
Yeah,
it took about 20 minutes.
20 minutes to
They
do the
opened
checks.
the valves fully into this special concrete trench, and so this is what we took care for. But it was a very, very fast acceptance of the tankers and emptying of the tankers.
Okay, how much is the cost for the plant, and also all over the overall cost for the per cubic meter of treatment here?
Okay, it was, I can tell you, the costs for the civil works and for all the equipment, fences and so on were about 4 million, and another 4 million for the euro. 4 million euro for the technique, for the instrumentation, and for the management for 1 year. Management, one person for 1 year.
Okay. So 4 million for the whole
8
thing.
million.
4 million for the construction.
Yes,
For the civil and the
equipment, in total, with all the buildings and so on, it was about 8 million euro.
8 million, so altogether. Okay, I mean, did you come to a price for, I mean, with the operation cost that you are also?
The operation costs per meter cube were finally not really optimized, but it was about, I think, 1.3, 1.5 euro per meter cube.
Of course, you are including the investment cost in this.
No, not the investment cost, just the
Only operation cost.
The cost for the chemicals, for the personnel, and for the electricity.
1.3. Huh?
Yes, it is. The chemicals are very costly. That is why we had this pre-treatment to take everything out what we could do.
Yeah, but it's €1, so 1.3 is. We're talking about
It
almost
is a
$2, right?
It is a very dirty wastewater, so we had to do a lot.
Yeah.
The optimization would have been, finally, also to separate all the simple tankers. What happened at first, when they offered this, the industry put some sludges in the tankers, not the wastewater. They kept the wastewater, or the water on site, and separated all the companies and brought also the heavy wastewater to this. This is a problem of management. This is a problem of politics also. So it can be optimized, but to be realistic, it is what I said.
Yeah. What type of biological process you have here?
What type of?
Biological process. Are you talking about MBR or what?
No, we have this normal activated sludge process, but added with this, we have a 2-cascaded system, and we have additional a process. We have a big reactor where the sludge is stored for more than 5 days, left without any organic affection, and then is recycled into the plant. So we have we call it ARS system. It is a bit too complicated to explain here, but I can do it later or send you some information if you're interested.
Okay. And the standards of the TSE, the treated sewage effluent now, the water that you are producing, to what level you are?
The standards for agricultural irrigation were fulfilled. There was one value on the limit, which we expected because we did not eliminate the salt. So the salt in the water was about a bit less than 2 grams per liter. Okay. As it came in, it came out, yes. But all the other parameters were fulfilled. We had no fat and grease, and the COD was about 50, 60 milligrams per liter. BOD was maybe 3, or I don't know. We didn't measure it. It was.
And the sludge, is it meeting US EPA Class A that you produce?
The primary sludge not. The primary sludge had to be burned. But the other sludge, the biological sludge, was set, they took it they used it for fertilizing the land.
I know, but is it US EPA Class A or some other standard?
This is a question I'm sorry I cannot answer. I don't know. I have to ask, but I can inform you. I can ask and inform you.
Thank you very much. Thank you.
Thank you, sir, for your very interesting presentation. Thank you very much. Actually, I have one small question and the other just some kind of clarification of your involvement. The first, I have, noticed that you were talking about a pre-treatment, but at the end we see a very clean water. That means all the treatments have been done in this in this plant. I might not understood it, or if you just clarify it. The other question is what's the kind or shape of your involvement here? Are you working as a consultant here, or as a contractor, or it's a sole source involvement? Did you compete with other technologies to go for this, for such a work, or it's just one-to-one partnership or dealership? Yeah, just to clarify the way, how did you approach this kind of taking these tasks on your shoulder? Thank you.
So first of all, it is a pre-treatment, and a very sophisticated pre-treatment in 3 lines with the heavy metal line, and then a final biological treatment. This is why the quality is as high as you see it here. It is not only a pre-treatment, it is both. It's a full wastewater treatment, as full as it can be. Just, even we have a chlorination at the end. I don't know whether it's necessary, but they like the chlorination. The second question is, we are normally a turnkey deliverer of these plants, but we found out that it's better to share the work with the local institutions. So we shared all the work we could share, which is cheaper to do on site, like buildings, like facilities, like sometimes also the pipes, for example, the big pipe for air. It was not done by us. They did it themselves, so it's much cheaper than we brought it from Germany in stainless steel or something like that. So we tried to share the works with our client. And the other part of the question was whether we had a competition. Of course we had a competition, yes.
Yes, and are there any, just a figure to show what's the cost of, per unit? For example, what is the cost of the operation for cubic meter of the wastewater,
As I told you before, it could be optimized, but at the moment it's between 1.5 euro per meter cubes for the running costs, not for the capital costs not involved.
Yes, and final note, if you allow me, please. Actually, I see it's some kind of new technology that you apply, you adapted yourself, and this way, if we have this problem and we want to solve it, and we want to establish some kind of transparent, regime for attracting different contractors or different companies to solve such an issue. You cannot unify the criteria among different technologies and different solutions. Here I see that you are just proposing a unique solution which is relevant to your company. Am I right?
This was the result of the tender. We made, and all others made, all our competitors also got some information about the wastewater, got the opportunity to take samples and to take part on these studies in before. And I think all the others, but I know it from my company, we were involved in we had a discussion process about our concept, and we changed it a little bit, the concept, and we adapted it, and we thought about it, the concept, from the conception side, we discussed it with the client. For example, this trench for acceptance was approved, and so we said, okay, we take this trench, it's very easy, they open this, it was not in our experience before, yeah? How to go with 400 tankers per day and how to manage that. This was on the side of the client, he was much more experienced than we were, but the wastewater treatment, the concepts for the wastewater treatment, the pre-treatment, also the odor control and the biological treatment, this was all in our concept, and we gave the architectural design completely responsible to the client, and he did the concrete works, the civil works.
Yes, thank you very much. Thank you.
Welcome.
Thank you, Dr. Müller-Blanke, for this interesting presentation and the discussion. With this, ladies and gentlemen, we come to the end of the second German Water Partnership session at the ACWUA's 5th Best Practices Conference. We thank you for your attention and for the fruitful discussions that we have. Thank you.